Hello, and welcome back to Shiksha de Casa. Today we're going to be looking at simple versus compound interest. And again, this is one of the most important units that you will cover in your entire high school math career. So today we're going to learn what is the difference between a loan that is growing according to something called simple interest and a loan that's growing according to something called compound interest. And these are how you know that you're successful when you've used investigation to determine the compound interest for a given investment. And we'll do that by repeatedly calculating simple interest. And then we'll compare what is the difference between simple and compound interest using a table of values and using a graph. And once we figured out this difference and we figured out how to calculate compound interest, we'll actually start to solve problems that involve calculating the amount or the future value of an investment using the compound interest formula. We'll also start to calculate the principal, which is sometimes called the present value. And then finally, once we found out how much our loan or our debt grows according to compound interest, how much it's worth in the future, then we'll calculate what is the total interest that's earned by finding the difference between that and the principal, which is the amount you started with. Suppose that you want to start selling a board game that you've made at home. Now, before you can actually sell this game and start earning revenue is, the money that you earn by selling products, you actually have to spend money on expenses. So before you can sell anything, of course, you need to buy some things. You need to buy the boxes. You need to print them out. You need to create the pieces and print out the rule books or whatever have you. Whenever you're selling products, of course, the first thing you have to do is spend expenses. How do you get that money? How can you spend money if you have not earned money yet? How do you get that money to start your business? Think about that for just a minute. There are a few different options. You could always get a job and save up that money yourself, or even ask a family member or friend. But the tactic we're going to focus on today is borrowing money from a financial institution. And that could be a bank, but it could also be something like a credit union. And when you borrow money, suppose a bank lends you that money to get your business started, what they will do is they will require that you pay back all of the money that you've borrowed, plus they will ask you to pay them $4 every year for every $100 that you borrow. So if you borrow $200, they'll charge you $8 per year. How much would you have to pay back? If you need to borrow $10,000 to get your company started, and you don't think you will make a profit for 5 years, so you need to hold this money for 5 years, how much will you have to pay back after 5 years? Take a moment, you can pause the video here and think about this and see if you can come up with that answer. Now let's see if you can get the same answer that I did. So the annual rate of something called interest, the interest rate, is basically, interest is the extra fee that you have to pay for borrowing money. And the rate of interest is, if it's $4 per $100 borrowed, 4 divided by 100 is 4%. So you need to pay 4% of the money that you've borrowed every year. That is the interest rate. And it's annual, that means per year. Well, if we're borrowing $10,000, 4% of $10,000, well, let's convert that to math. 4% as a decimal is 0.04. We just divide by 100. Of means we need to multiply, and 10,000 was just 10,000. So 0.04 times 10,000 would give us 400. That means that if this is our timeline, in year 0 we borrow $10,000, and we need to pay back $400 for that year, 4% of 10,000. In the next year, well, we still have this debt outstanding, so we need to pay back we need to pay a fee, the interest of $400. In year 3, we need to pay another $400 in interest. Same with year 4, another $400. And finally, in year 5, we pay our final fee of $400. In total, how much money will you have to pay back? Well, we can't just add up the interest to get $2,000. We also have to pay back the money that we borrowed in the first place. They didn't just give us that money for free. We have to give it back. And then we have to pay back all the interest. So in total, how much money do we have to pay back? $10,000. That's our principal. That's the amount that we borrowed at the start. Plus $400 times 5, times the number of years. How did we calculate $400? We took 0.04, that's the interest rate, and multiplied it by the principal. So this is the principal P. The way we got 400 was we did P times R, the principal, times the interest rate. And then we have to multiply that by T. That is the term, that is the number of years. This is the formula or the equation for simple interest. How much you have to pay back if you borrow a certain amount of money for a certain amount of time at a certain interest rate. So that is the formula for simple interest. And notice that because there's a P in this term and a P in this term, we can do something called factoring. We can common factor this. We can divide both of these by P, and we end up with P divided by P is just 1. Anything divided by itself is 1. And PRT divided by P will cancel out the P's, and we'll end up with just RT. This would be P divided by P is 1. 1 times RT is just RT. So this is actually a slightly better version of the same formula. Notice that when we multiply this by P, we will end up right back here. P times 1 is P. P times RT is PRT. Now I can use this formula to find out stuff like, how much would I owe if I borrowed $5,000 at an annual simple interest rate of 12%? How much would I have to pay back after 1 year? So hopefully you were able to use this formula. This is the one that we're going to try and use so that we can learn the compound interest idea a little bit better. I'm going to start off with the formula, and then I'm going to look at my problem here to find out which of the variables I actually know. I know that the principal is 5,000. I know the interest rate, that's 12%. The principal is 5,000. And the term is the number of years. That's only 1 year. And so if I take these variables and I plug them in to my formula, I would get 5,000 times 1 plus 0.12, that's 12% as a decimal, just divided by 100, times t, which is just 1 year. So let's see what this turns out to. What is 0.12 times 1? Well, that's just 0.12. Plus 1 would be 1.12. And if I multiply that by 5,000, I get 5,600. So this is the amount that I would owe on a loan after 1 year if I borrowed $5,000 at 12%. So now let's start our investigation for this lesson. So Frank needs $5,000 to start his company. He borrows it from a bank at an annual rate of simple interest of 12%, but after 1 year, he has no money to pay it back. And then in order to pay the bank back, well, he just goes to a different bank and says, hey man, can I? So we know that, just because of what we just did, we know that his debt of $5,000 grew by $600. He needed to pay back $600 in interest after the first year. And just because of our understanding of simple interest now, we know we can multiply this by 1.12 to get 5,600. He needs to pay this back to the first bank, and he doesn't have the money. So he goes to another bank and borrows $5,600. and he pays the first bank back. Good for him. But after the second year, he still has yet to make a profit. He actually owes more money. He doesn't just owe $5,000, he owes $5,600. And so he goes to a third bank and again borrows another amount of money. How much money would he have to borrow to pay back this loan? Remember, he owes $5,600, but it grew at the same rate. It grew by 12% as well. So how much money does he have to pay back? So what happened here, just before we get to our answer, what happens here is we took the interest and we added it to the principal and we created a new principal. When you do this, Frank is now going to start paying interest not on $5,000. He's going to start paying interest on $5,600. He's going to pay interest on his debt and on the first year's interest. When you do this, when you add the interest to the principal to create a new higher principal, this is what's called compounding. To compound means to put together, like compound words, right? Like the word bittersweet is a compound word meaning bitter and sweet. This is compounded interest. We took the principal and we added it to the interest. So you might say, oh, so he's got to pay back another $600 in interest because you're seeing the $600 here. But unfortunately, it's going to be higher because 12% of $5,000 is $600, but 12% of $5,600 is going to be more. In fact, he will have to pay back an extra $672, right? This is 12% of $5,600. So this amount is actually a bit larger. And if I want to find out what is his total amount that he has to pay back to these guys, what I can do is take 5,600 and the same thing, I can multiply it by 1.12 to get $6,272. Now this is the amount that he borrowed from the third bank to pay back the second bank. And Frank's problems are just getting bigger and bigger, right? He doesn't just have to pay back the initial amount he borrowed, 5,000. Now he's got to pay back over 6,000. But at the end of the third year, how much money does he have to pay back then? This $6,272 is also growing at the same rate. Again, all we have to do is find out what is 12% of his debt. And when we do that, we find out that he's going to pay another $750 in interest, $752.64 specifically. So when we add these together, now he has to pay back $7,024.64. And the way we've got these numbers, where we can take the original principal and multiply it by 1.12. That is 112% to find the new amount that he owes. And then if we want to add the interest to find out this amount, again, we just multiply it by 1.12 again. Now we're taking 5,600 and multiplying it by 1.12. And now we're taking 6,272 and multiplying that by 1.12. So whenever we're trying to make up an amount, a debt, or an investment grow according to an interest rate, we can multiply that number by 1 plus the interest rate for that period. And if it continues growing for many of the same periods at the same rate, we can just continue multiplying by 1.12. So for this part of this investigation, I'll ask you in just a second to pause the video and complete this table. But what you're going to do is find the amount of a $10,000 loan after 10 years. If it grows at 12% per year and it compounds every 6 months. So we're going to fill out the table to find out how much would we owe after the 20th period. Remember, it compounds every 6 months. It doesn't compound over the full year. So what I'm going to do just to help us start off is use that idea of simple interest. So each period we take the principal and we multiply it by 1 plus RT. The interest rate is 12%. That's R. The term, every 6 months, that's not even a full year, right? How many years is 6 months? Half a year. And so we would not get the full 0.12 times 0.5 is 0.06. We would not get the full 12% growth because we did not wait a full year. Instead, we would only get 6% every half year, every 6 months. So after 6 months, which is one period, a period is an amount of time. So after the first period of 6 months, we take 10,000, that's our principal, and we multiply it by 1.06 to find out that we now owe $10,600. After the next period of 6 months, again, we can do the same equation, except our principal is going to change, right? Our principal is $10,600, but again, we will multiply by 1.06 to get $11,236. To find out how much it will be after 3 periods, I can take this number and multiply it by 1.06 to get $11,910.16. So pause the video right here, fill out this table, find out how much it would grow to if we did not compound. So in other words, use the simple interest formula to find out how much it would grow to after 10 years, and then plot both of those on a graph both of those situations. And this should take you about 10 or 15 minutes. So hopefully you were able to complete this by now. And if you haven't yet, then of course feel free to pause and keep going. But this is what I got. So I recognize that every time one period of 6 months ends, the amount of this loan grows by 6%. So I just need to multiply by 1.06. So I did that 3 times so far. I'm going to do it another time to find out after 4 periods of 6 months. So this is after 2 years. And then times that again, and again, and again. And I'll just keep doing this until I've completed 20 periods of 6 months. And 20 periods of half a year each is a total of 10 years. So I finally will end up getting, my loan will grow after 10 years to $32,071.35. Now, if I didn't, this is the end of question A, right? This is how big my loan is going to grow after 20 periods, after 10 years, if it compounds every 6 months. But how much would it grow to if it did not compound? So using the simple interest formula, I will still keep this the same, except my rate is the same, the principal is the same, but my term is the full 10 years. So I don't need to do this 6% every single time because it's not compounding. It's not growing by 6% every 6 months. It's just growing by 12% of the principal, of the original amount every year. So $12 for every $100, and it does that for 10 years, which would give me $22,000 flat. Now notice the difference between these two. Just by compounding it every 6 months, the interest rate was the same, but just because we compounded it every 6 months, it grew to more than $10,000 higher than it would have if it did not compound. This is the power of compound interest, and I'll show you another when I graph these, and hopefully you've graphed it already and you're already seeing how much these are different. But before we do, let's just take a look at and see how would we calculate this amount without having to do this entire table, because we don't want to do this every single time, right? Notice that we're doing the same thing. We're starting with our principal, 10,000, and we're multiplying by 1.06 again and again and again and again and again. And what is it? What operation are we doing when we are repeatedly multiplying by the same number? It's exponentiation. To get this number, I started at 10,000 and I multiplied it by 1.06 20 times. And that got me 32,071.35. In fact, if you put this into your calculator, you will find out that that is exactly the number you get. This is the formula for compound interest, and we'll dissect this in just a second, but before we do, let's graph both situations. Your graph should look something like this. So here you see simple interest growing in a nice straight line. Every year you get charged the same amount of interest. So every year your loan grows by the same amount. It's just $1,200, I believe, every single year for 10 years. But with compound interest, your loan grows like very similarly, very slowly at first, and then it starts to speed up. And now it's getting even faster. It's growing faster and faster and faster. And if you recall, exponential relations work exactly like this. They start off by growing slowly, but then they very quickly speed up and they start growing faster and faster and faster. And so this, if we look at the number of periods, which is in the exponent, 20 periods, that is the exponent, we recognize that compound interest grows exponentially because the independent variable is in the exponent. And that means it grows slowly at first, but it grows faster and faster and faster over time. So when you add the interest of a loan or an investment to its principal to create a new principal, what are you doing? You're doing something called compounding the interest. To compound means to put together. Compounding interest makes a principal grow a lot faster than simple interest like we saw in that graph. When you're given an annual interest rate, which is R, and a term, which is always an amount of time that's expressed in years, that's T, we can use the simple interest formula, which is pretty easy. But later on, you might be given something called a compounding frequency, which we're going to use the variable f to denote frequency. That will tell you how many periods there are in 1 year. So for example, if it compounds annually, that means it compounds every single year. So the frequency is 1 period in 1 year. If it's semi-annually, that means it compounds every 6 months. And that means that the frequency is 2. There are 2 periods of 6 months in a year. If it compounds quarterly, there's 3 months. It compounds every 3 months. And how many periods of 3 months are there in a year? 3, 3, 3, 3 makes 12 months in total, so 4 periods. If it compounds monthly, there's 12 months in a year. If it compounds weekly, there's 52 weeks in a year. And if it compounds daily, that is 365 days in 1 year. So we can find out what is the interest rate for 1 period per period. And that's different from the annual interest rate. The annual interest rate is the rate for a full year. But if a period is only every 6 months, then just like we took 12% and divided it by 2 to get 6% for 6 months in our investigation, we take the annual interest rate and divide it by the frequency to find the interest rate per period. And we're going to use the variable I to signify the interest rate in 1 period. If we want to find out how many periods there are in the entire term, just like we took 10 and multiplied it by 2 to get 20 periods in 10 years, to find out the number of periods, we'll use the variable n for number of periods. We can take the term, the number of years, and multiply it by f, because f is the number of periods per year. So if 1 year has 4 periods and we're doing this for 15 years, 4 periods per year times 15 years would give you 60 periods in the entire term. And each period has its own interest rate that's different from the annual interest rate. So the formula is to calculate the total amount of a loan. If it's growing with compound interest, we're going to use this formula, P times 1 plus I to the power of n. P is still the principal, that's the amount that you borrow at the start of a loan or at the start of an investment. I is not the interest rate, it's the interest rate for one period. And the way we calculate that is we take the annual interest rate divided by the frequency. N, the exponent here, is the number of periods. And so we take the term, which is the number of years, and multiply it by how many periods there are in each year. And that's how we find N. And then we can use this formula pretty easily to calculate the total amount at the end of the term. If we want to find out how much of our loan is just interest, all we have to do is take this future amount and subtract the principal, the amount that we borrowed in the first place. And we would find out how much interest are we paying in total on this loan. In this example, on August 7th, 2004, Google first began selling shares to the public. Remember, a share is like one tiny piece of a company. So you could own a piece of Google for just $2.71 in 2004. Every year, on average, Google grew. It became more and more valuable as a company. And the price of one share increased by 57% each year on average until 2023. So if you bought $100 worth of Google shares at its initial public offering, its IPO, in August of 2004, how much would your shares be worth now? So if we want to calculate the total amount of a loan or an investment that's growing with compound interest, remember we're going to use this formula here, okay? So P is the principal, that's $100. That's how much you invested in 2004. So that is $100. But if I want to find out the interest rate per period, I know that it grew 57% each year. So the frequency is 1. The frequency is there's one period each year because we're only talking about annual growth here. And if the frequency is 1, then these two equations are really easy, right? The interest rate for one period is still going to be 57% divided by 1. Because one period per year, we don't need to divide this at all. The interest rate is just going to be 0.57. That's 57% as a decimal. In 1 year, because 1 year is one period here, it only grows annually, it's going to grow by 0.57. How many periods are there between 2004 and 2023? Well, if each period is a year, I'm really asking the question, how many years between these two? And I could just subtract them to find 19, right? The difference between these two is 19 years, and 1 period per year would give you 19 periods in total. And now that I have all three of my variables, the principal, the growth rate per period, and the number of periods, I will just use my compound interest formula. So this is 100 times 1 plus 0.57 to the power of 19. I would encourage you to pause the video here and evaluate this on your own. Find out what is the amount of your shares. Remember, you bought $100 worth of shares in 2004. If you want to sell them in 2023, how much would they be worth? Well, to evaluate this formula, the first thing you do is 1 plus 0.57, right? You always do brackets before you do anything else in your order of operations. So that's 1.57. And then you do the exponent before you do anything, before you multiply. BE, exponent is next. And this gives you $527,343.26. And if you're saying to yourself, hold on, I must have done something wrong, there's no way that my $100 grew to $500,000. You're absolutely wrong. Like that, there is a way, and that is the power of compound interest. Growing by 57% each year means it's growing by a larger and larger amount every single year. It's growing exponentially. And you could sell those $100 of shares that you bought in 2004, you could sell them in 2023 for over $500,000. This is how people save so that they can retire. They invest in companies. They don't just put their money in a bank account, because when you just leave your money in a bank account, the cost of living each year goes up by 2%. And so even if you bought $100 worth of stuff in 2004, you cannot buy the same things with $100 in 2005 because things are more expensive. And you can buy even less in 2006. So you can't just keep your money under your mattress in your house, or you can't just keep it in a checking account in a bank. You need to put your money somewhere where it will grow with interest. Now, it doesn't have to be 57% interest. This is really extremely high. It's unrealistic that something could keep this up over such a long period of time. Although Google certainly has. This is actual real data, right? So you have to make sure that you're investing really, really wisely. What if you took a loan? How much interest would you pay on a 4-year loan of $15,000 if it grew at 6.8% per year and compounds semi-annually? Well, to find out the total interest, we need to know how much is our loan worth at the end of the 4 years. And then we have to subtract the amount that we borrowed just to find out how much interest we're paying. And so $15,000 is our principal. Our interest rate per period, remember this is compounding semi-annually, that's every 6 months, if you refer back to that table. And so the frequency, how many periods are there in 1 year if one period is 6 months? The frequency is 2, because there are 2 periods of 6 months in a year. So the interest rate for one period per period is not going to be 6.8%. It's going to be 6.8% divided by the frequency. So 0.068 as a decimal, just divide by 100. And then divide that by 2, because we have to divide it by the frequency, gives us 0.034. So the interest rate for one period of 6 months is 3.4%, not the full 6.8%, because we did not wait a full year. How many periods are there going to be in 4 years? There are going to be 8 periods, right? Because each period is 6 months. And so there are 2 periods in a year. And 2 periods times 4 years, that's our term, is 8 periods in total. And when we use our formula, P times 1 plus I to the power of n, I is 0.034. We will add that to the number 1 to get 1.034. And then do 1.034 to the power of 8. Times 15,000, and that would tell us that our loan has grown to almost $20,000. Now, how much interest did we pay? This is how much we have to pay back, but this includes the principal. So all we have to do is take $19,599.98 and subtract the principal of $15,000 to find out that the interest we paid is $4,599.98. You have to repay $19,000, of which $4,000 will be just interest. In this next example, to save up for their first year of college, which will cost $2,686, Levin wants to invest some money in when they're in grade 9. And this is 4 years before they actually will go to college. So their money will have 4 years to grow. And they want their money to grow, and eventually at the end, they want the future value to be $2,686. And they look around, they find an investment product, like a mutual fund or maybe a stock, that guarantees 2.7% growth per annum. Per annum means per year. And it actually compounds weekly, which is really nice. Compounds really, really frequently. How much should they invest today in order to have their money grow until it reaches this future amount? Well, The amount that we want in the future is what we know now. We don't know the principal, right? We know that in the future we need to get $2,686. The interest rate per period is 2.7% per year. So we have to divide that by the frequency. And how many weeks are there in a year? 52. So we'll take 0.027 and divide it by 52. Now this does not give us a nice easy number. So I'm not going to round that number. I'm going to leave it as this expression. This is the interest rate per period. Okay? And then I have to find out the number of periods. So if they're going to graduate in 4 years, they have 4 years of growth. How many weeks is that? 4 times 52, which would give us 208 weeks, 208 periods where their money is growing a little bit at a time until it hopefully reaches $2,686 in the future. So let's use our formula here. Let's plug in all the numbers that we know. And now, how do we find out P, the principal? Well, to do this, we need to go all the way back to our algebra. Okay? To isolate P, to get P all by itself, we need to, because it's being multiplied by this, and if you put this into your calculator, it'll give you some number. If we divided the right side by that number, whatever that number is, that number is approximately 1.114. So this is P times 1.114. If we divide both sides by that number, this part will just disappear. Because when you multiply and divide by the same number, those are opposite operations and they cancel out. And whatever we change one side, we have to change the other side by the same thing. And so we end up, this ends up happening, and we end up with 2,686 divided by this number. Now, if you can't do this, if you don't know how to do this on your calculator, I would just punch this into your calculator and do 2,686 divided by answer. Most calculators have, scientific calculators have an answer button. And it will take the exact number and use that for the calculation. And that will tell you that P is equal to approximately $2,420. So if you have $2,420 today, Levin would have to invest that, and then over the course of 4 years or 208 weeks, it would grow to $2,686 exactly. Determine how much money you will have if you have $500 and you invest it for 6 years at 4% per year, compounded semi-annually. So this question is very similar to the example number 2, but what I'm going to do here is I'm going to show you a diagram of what's happening. So if this is your term, you're investing this for 6 years, so that's 1, 2, 3, 4, 5, 6 years, and you're starting with $500. How much would this end up being? Well, it's compounded semi-annually, which means there are 6 months in one period. The first year has 2 periods, the next year has 2 periods, the next year has 2 periods. In total, we have 6 times the frequency, which is 2, 12 periods in total, right? And the number of periods is 12. Now we're getting 4% per year, but we're not waiting a whole year before we compound. So how much are we getting in just one period? 4% divided by the frequency, which is 2, is 2%. And so $500 is growing by 2%, and the way we do that is we multiply it by 1.02. And it's $510 after 6 months. And then we can multiply it by 1.02 again to find out how much it is after 1 year. And we can keep doing this, just multiplying by 1.02 again, until we have done this a total of 12 times to find the amount. So the amount is 500 times 1.02 to the power of 12, which is approximately $634.12. This is what that looks like on a graph. If this were to grow with just simple interest, we would end up with $620, but because we've compounded, it's gotten us $14 more. Now this doesn't seem like a lot because the interest rate is quite small, And it's not compounding really frequently at all. It's just semi-annually. The higher the interest rate, the more frequent the compounding, the faster it will actually grow.
If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.